Hi, Assalamualaikum and good day. Today you are going to learn more on power series that is on Maclaurin series. These are the objective of today's lesson. Hopefully by the end of this session, you are able to explain the Maclaurin series and use this series to approximate functions. Before we discuss further on Maclaurin series, let's do some recap on the Taylor series first. There are two formulas to be used for this series. The first formula is known as Taylor series about the point x equal to a, in which the function fx is equal to fa plus f prime a multiplied with x minus a plus f double prime a over 2 factorial multiplied with x minus a square plus so on. The second formula is known as Taylor series in power of x, in which the function fx plus a is equal to fa plus f prime a multiplied with x plus f double prime a over 2 factorial multiplied with x squared plus so on. By putting a equal to 0 in the Taylor series, we obtain the Maclaurin series, which is represented as fx equal to f0 plus f prime 0 multiplied with x plus f double prime 0 over 2 factorial multiplied with x squared plus f triple prime 0 over 3 factorial multiplied with x cubed plus so on. Maclaurin series is a special case of Taylor series. Following are some common Maclaurin series that you need to know. First is the Maclaurin series for sin x. To obtain the expansion, you need to differentiate sin x few times. Then, find the values of f0 and its derivative by replacing x with 0. Once you calculate all the values, substitute accordingly into the Maclaurin's formula and simplify, you will obtain sin x equal to x minus x to the power of 3 over 3 factorial plus x to the power of 5 over 5 factorial minus x to the power of 7 over 7 factorial plus so on. Take note that for Maclaurin series, you can determine the pattern of the expansion and come out with the next few terms without doing further differentiation. For example, when you refer to the expansion of sin x, you will notice that the power are all odd power and the sign is alternate. From the pattern, you can get the next term of the expansion, which is plus x to the power of 9 over 9 factorial minus x to the power of 11 over 11 factorial plus so on. Next is the Maclaurin series for cos x. To obtain the expansion, you need to differentiate cos x few times and find all the values by replacing the x with 0. Substitute these values accordingly into the Maclaurin's formula and simplify, you will obtain cos x equal to 1 minus x to the power of 2 over 2 factorial plus x to the power of 4 over 4 factorial minus x to the power of 6 over 6 factorial plus so on. Take note that for the expansion of cos x, it involves even power and the sign here is alternate. Based on the pattern, the next term of the expansion should be plus x to the power of 8 over 8 factorial minus x to the power of 10 over 10 factorial plus so on. Following is the Maclaurin series for 1 plus x to the power of n, which is also known as the binomial series. To obtain the expansion, you need to apply the same process that you did for sin x and cos x. This is how we obtain the exponential series, which refers to the Maclaurin series for exponent x. Take note that no matter how many times you differentiate the exponent x, you will obtain the same function. Replace x by 0 and simplify. You will obtain the expression as follows. Exponent x is equal to 1 plus x to the power of 2 over 2 factorial plus x to the power of 3 over 3 factorial plus so on. Following is the Maclaurin series for ln 1 plus x. Make sure you know how to differentiate the function correctly. Replace x by 0 and simplify. You will obtain the expansion of ln 1 plus x, which is equal to x minus x squared over 2 plus x to the power of 3 over 3 minus x to the power 4 over 4 plus so on. Refer to example 3. You need to obtain the expansion of x exponent negative 2x as far as the term in x to the power of 4. As you need to obtain the Maclaurin's expansion to the given function, the formula to be used here is as follows. Differentiate fx equal to x exponent negative 2x, you need to apply the product rule, which is uv prime plus vu prime, as shown on the right side. As you need to expand up to x to the power of 4, you need to differentiate the fx 4 times. After differentiate 4 times, calculate the f0 and its derivative by replacing the x by 0. Then substitute the values accordingly into the Maclaurin's formula and simplify. You will obtain x exponent negative 2x equal to 0 plus x minus 2x to the power of 2 plus 2x to the power of 3 minus 4 over 3x to the power of 4 plus so on. There is an easier way to find the expansion for this function, that is by ignoring the x and take only the exponent to be differentiated. Differentiate exponent negative 2x 4 times, then find all the values by replacing the x by 0. Substitute these values accordingly into the Maclaurin's formula and simplify. You will obtain the expansion of exponent negative 2x, which is equal to 1 minus 2x plus 2x to the power of 2 minus 4 over 3x to the power of 3 plus 2 over 3x to the power of 4 plus so on. Multiply the whole expansion by x and simplify. You will get the Maclaurin series for x exponent negative 2x up to x to the power of 4. See that the answer here is the same with the one that you have obtained using the first method. In case you are having problem to differentiate exponent negative 2x, you still can proceed with the basic function, which is exponent x. Differentiate exponent x 4 times and substitute all the x with 0. You will get 1 as the answer for f0 and the derivatives. Substitute the values accordingly into the Maclaurin's formula and simplify. You will obtain the expansion of exponent x equal to 1 plus x to the power of 2 over 2 factorial plus x to the power of 3 over 3 factorial plus x to the power of 4 over 4 factorial plus so on. Next, replace all the x with negative 2x and multiply the whole expansion that you have obtained by x and simplify. You will get the same expansion of x exponent negative 2x up to x to the power of 4 as obtained using the first and the second method. Take note that you can only apply method 2 and method 3 for Maclaurin series, not for the Taylor series. And take note that you can only ignore the polynomial function, not other than that. Now, refer to example 4. You need to find the Maclaurin series of fx equal to x squared exponent x as far as the term containing x to the power of 4. Hence, estimate the following definite integral correct to 3 decimal places. First, you need to find the Maclaurin's expansion of the given function using the following Maclaurin's formula. As given x squared exponent x, you can ignore the x squared. Just differentiate the exponent x. Differentiate exponent x 4 times, you will get the same answer, which is exponent x. Find all the values by replacing the x with 0 and substitute the answers accordingly into the Maclaurin's formula and simplify. You will obtain exponent x equal to 1 plus x to the power of 2 over 2 factorial plus x to the power of 3 over 3 factorial plus x to the power of 4 over 4 factorial plus so on. Then multiply the whole expansion that you have obtained by x squared and simplify. You will obtain x squared exponent x equal to x squared plus x to the power of 3 plus x to the power of 4 over 2 plus so on. Next is you need to integrate the expansion that you have obtained one by one. Substitute the interval 0 and 1 accordingly and calculate. You will get 0.683 as the answer for the given definite integral. Refer to example 5. You need to obtain the Maclaurin's expansion of ln 1 plus cos x as far as the term in x to the power of 4. Before applying the Maclaurin's formula, you need to differentiate the given function 4 times. For this example, you need to differentiate the whole function. Make sure you differentiate correctly. Differentiate ln 1 plus cos x. The answer is 1 over 1 plus cos x multiplied with negative sine x. Negative sine x here refers to the derivative of 1 plus cos x. To differentiate f prime x, you need to apply the quotient rule. Simplify your answer before you differentiate once again. Once you differentiate 4 times, calculate the values by replacing all the x with 0. Substitute the values accordingly into the Maclaurin's formula. You will obtain the expansion of ln 1 plus cos x equal to ln 2 minus 1 over 4 x squared minus 1 over 96 x to the power of 4 plus so on. To check your understanding on the Maclaurin series, please do the following 3 questions. In the next lesson, you are going to learn about binomial series. So,